Assalamu alaikum everybody. I'm here with a new lecture on X-rays. First year class, chapter number 2, atomic structure. So here we have a brief introduction of X-rays, but I'll try to explain as much as I can by myself. So what happened in 1895? William Röntgen. First of all, let me give you a brief introduction of X-ray. X-rays are also called Röntgen rays because they were discovered by Röntgen. There are two ways to produce X-rays. What? Two ways. One is a Röntgen rays, and second one is the Brennstrahlung. Actually, it's a German name, which means in English we usually say Brennstrahlung, but it's Brennstrahlung. Okay, the real one scientist who discovered the electron rays. Firstly, we will study the William Röntgen phase, which is the interaction between the electron and nucleus, and high speed of electron is strike with heavy metal in discharge tube. So what happens then when for example we have an atom here, okay, this is an atom, okay, this is an atom and consisting of electrons and neutron over here. A high speed of electron, which is or cathode ray, is striking towards the nucleus electron and kicking the electron out of this atom and leaving a space of energy over here. In the equation of spectrum and in orbital, we have previously discussed that there is an emission of light spectral energy when a space of electron is empty and an electron from another shell covers this space. What happened? That electron which is striked over here and kicked this electron away, and वो खुद इलेक्ट्रॉन भी बाहर चला गया और उसने उस इलेक्ट्रॉन को भी बाहर निकाल दिया, मींस दोज बोथ इलेक्ट्रॉन्स गो आउट। और यहाँ पर जो जगह बच गई, अब जो ये जगह तो खाली हो गई ना भाई, तो ऊपर वाले शेल से जब यहाँ पे एनर्जी आई, इलेक्ट्रॉन आया, तो हमने ये बात पढ़ी है कि जो डेल्टा इन एनर्जी जो होता है, डेल्टा को हाउ शुड आई रिप्रेजेंट, चेंज इन एनर्जी is equals to the E2 minus E1, which means जब हम बड़े ऊपर वाले जो इलेक्ट्रॉन जो आया हमारे पास, उसकी एनर्जी से हम इलेक्ट्रॉन 1 की माइनस कर देंगे तो हमें जो चेंज इन एनर्जी है वो मिल जाएगा. And the important thing here to note is that the change in energy is that emission, which अब वो emission क्या हुई, वो यूं बाहर आ गई, और वो जो बाहर आई उसको हमने नाम दे दिया एक्स रे का. ये रोएंटन रे थी जो हमने डिस्कवर की. ठीक है, इस तरह से हुआ कि क्या नाम है, हमें न्यूक्लियस का पता चला. अभी वी आर गोइंग टू डिस्कस फर्दर मोर प्रॉपर्टीज. Firstly we should read them. William Röntgen 1895 accidentally discovered that if cathode rays are pointed to fall on a heavy metal target. क्या कहते हैं कैथोड रेस, जब हैवी मेटल टारगेट के ऊपर जाके क्या नाम है बम्बार्ड हो, तो दे आर प्रोड्यूस सम पेनिट्रेटिंग शॉर्ट वेवलेंथ रेस. तो वो क्या करती हैं, कोई पेनिट्रेटिंग शॉर्ट वेवलेंथ रेस को फॉलो करती हैं, which we are going to discuss later in detail about the characteristics of X-rays. He named them X-rays. The X-rays are electromagnetic radiation of very high frequency, depending upon the nature of an tungsten filament is used for this purpose. X-rays are emitted from the target in all directions. X-rays अभी इधर जो निकला है इलेक्ट्रॉन से जो एनर्जी निकली, it can go into any direction, which means is can go into any direction. It is a small portion of them is useful for purpose through the windows. Purpose. A small portion of them is used for useful purpose through the windows. The wavelength of X-rays produced depend on the nature of the target metal. Every metal has its own characteristic X-ray. अब एक और बात जो I want to explain over here. अब एक ये atom है, we know that electron have different shells. For example, this have two shells, or we say two shells हैं इसके electron के. यहाँ पे एक electron है, ये so ignore the picture everybody, please. So sorry for this, but I have so bad drawing. Cathode rays which strike this and kick this electron away outside of the atom. So definitely there will be a third shell. From the third shell, electrons will be jumping towards this. This could happen even with this electron. हो सकता था कि ये इलेक्ट्रॉन बाहर जाता और ये इलेक्ट्रॉन आ जाता. और हमने ये बात पढ़ी है कि हायर एनर्जी जो ऑर्बिट होता है, वो हाईएस्ट यहाँ पे एनर्जी क्या जो होती है, वो बाहर जाते जाते हाई होती है. एनर्जी बिकम्स ग्रेटर मूविंग आउटसाइड ऑफ द न्यूक्लियस. मतलब इस वाले में लेस एनर्जी, इस वाले में उससे थोड़ी सी ज्यादा, और उसमें उससे थोड़ी सी ज्यादा. अब अगर इलेक्ट्रॉन यहाँ से गया तो फिर यहाँ वाली एनर्जी को हम इसमें से माइनस करेंगे, which will be different chain engine energy. But when electrons move from over here, so we will minus the energy from energy 3 minus energy 2, which will be the change in energy, which will be different from the change in energy of shell 1 and shell 2. So this tells us the nature of the target metal. Depends upon wavelength of जो एक्सरे होती है वो क्या करती है, नेचर ऑफ टारगेट मेटल पे डिपेंड करती है, क्योंकि वेवलेंथ इज लाइक जितनी ज्यादा एनर्जी होगी वो उतनी ज्यादा वेवलेंथ चलेगी. अब यहाँ पे ज्यादा वेवलेंथ होगी क्योंकि यहाँ ज्यादा एनर्जी होगी, यहाँ कम वेवलेंथ होगी क्योंकि यहाँ कम एनर्जी होगी. सो दिस इज द रीजन फॉर द डिपेंडेंस ऑफ टारगेट मेटल ऑन द वेव एक्सरे. और हर मेटल की एक्सरे की अपनी कैरेक्टरिस्टिक होगी, क्योंकि अपनी एनर्जी होगी, अपनी एनर्जी के साथ फिर अपनी फ्रीक्वेंसी बदलेगी, फ्रीक्वेंसी बदलेगी तो वो उसका वो भी बदलेगा, क्या नाम है, वो वेवलेंथ भी बदलेगा. सो दिस इज द रीजन. अब नाउ वी आर गोइंग टू डिस्कस सम कैरेक्टरिस्टिक्स व्हिच आर written over here, but I will show you some pictures for that. Okay, like this side. Up here you can see which is types of electromagnetic radiation. Where there is X-ray, you can see the frequency. The frequency of X-ray is very high. Why is the frequency high? Because the wavelength है जो यहाँ से लेके यहाँ तक का distance है, which is less, and frequency becomes high, means number of waves passing from a particle will become more because of high wave, low wavelength and high frequency. Up we discussed it कि हाई फ्रीक्वेंसी होगी, लो वेवलेंथ होगी, और these x-rays cannot be seen by eye से नहीं हो सकते, or they have no deflection in neither in the north pole in the magnetic field nor in the electric field, because it does not have any charge, any mass, because they are the energy particles. They are energy. X-ray is an energy particle. The wavelength of this is from 0.1 angstrom to 0.1 to 1 angstrom. Okay, 1 angstrom. Very bad with writing. You can write it by yourself. Listen, 0.1 angstrom to 10 angstrom is the wavelength of an X-ray. It travels with the speed of light. The velocity is as the speed of light that we have. Put it over here. You should write. I'm writing over here. Wavelength जो है वो है short and ranges from 0.1 short 0.1 angstrom. 0.1 angstrom to 10 angstrom. Frequency high. Frequency high. Velocity is the speed of light. Velocity is the speed of light. They travel very faster because they have no charge, no mass, which means no deflection, and no charge, no mass, which means no deflection in magnetic field and neither in the electric field. The penetration power is very high due to no charge, which means if it will not cause any friction in this, like in the atom or in the radiation, which will directly make it very penetrative. Kinetic energy is directly proportional to attraction. We know this. As the attraction will be much, the kinetic energy will be much. And photographic plate, which is covered by silver bromide. We know, have you seen a silver plate, which is also known as the X-ray plate? When we go for X-ray and we have a black paper plate like this or a paper. So this is affected by X-rays. It's affected by X-rays and shows their flashes, or what do we say, remains there whenever it is reflected through it, it flashes inside this. It flashes the silver bromide painted photographic plate. One more thing that I also want to add over here is that the ionized gases, they can ionize gases and solid gases, ionized, solid, liquid, and gases. Why? They don't have mass, they don't have charge, but why do they do this? Yes. Because of energy, because of the energy that they possess, let them ionize the gas particles. They are used to destroy cancer cells. Analyzing bone, here we have seen that they are used to analyzing the bone structure, that we have got any fracture or is our structure fine. To find the shape of crystal, crystallography is done through X-rays. So this is the thing. Okay. I hope you all have understood today's lecture. So, Allah Hafiz.